Energy efficiency and thermal performance on healthcare facilities. Welcome to Building Knowledge 101. Learn about ways to enhance energy savings and deliver temperature control for increased occupant comfort and reduced HVAC usage. Operating costs at healthcare facilities is quite high. Hospitals are looking for ways to reduce or control operating costs. As we expand the glazed building envelope, we need to focus on optimizing energy efficiency. Curtain walls are available with higher thermal performance options and IGUs with increased thermal performance. All of this is to restrict heat moving through the exterior walls and reduce the HVAC loads and improve the efficiency of the building and improve interior thermal comfort. Look at this image of a library from Colorado Springs. You can see on the outside barren trees, and the exterior is cold and there's snow on the ground. But if you look at the inside, it's a very soft, warm, more inviting environment. But dividing these two is a high-performance aluminum framing system with high-performance insulated glass units and warm edge spacers. Elevations like this do an excellent job of keeping the warm inside and not forcing the heat to have to run at higher loads to make up for heat loss through the frames. Same in a hot environment. If we were down in Miami, Florida, we'd be concerned about keeping heat out of the building so we don't have to run the HVAC on the inside for longer times. So let's look at conductivity and how it works. Aluminum is a great conductor of temperature. It transfers cold very rapidly. To prevent heat loss, there is a need to introduce some type of a thermal break into the frames to separate the interior metal from the exterior metal. Non-conductive material is needed to break the frame so that you have a thermal break in it that stops the progress of heat through the frames. Looking at this thermal image, you can see on the right is a non-thermal frame. And if we look at the chart, where darker colors like up here is at 30 degrees, and then the warmer colors here at 70 degrees, you can see heat is being pulled through this frame to warm the exterior. So the exterior is right around this color. So it's being warmed by heat being pulled through the frames. Now looking at this where you have a thermal break in it, we can see the exterior is this darker color. So it's closer to the 30 degrees. So it's staying cold on the outside and the interior is keeping warm. So we're down here with this brighter green color. So the thermal break is keeping our heat on the interior and cold on the outside and not having heat flow through the frames. So if we look at these section cuts, on the left is a non-thermal storefront system. And I'm going to take a piece of glass, insulated glass unit, has a center glass U factor of 0.28. And in a non-thermal frame, the system performance is 0.47. So when we're talking about thermal performance and U values, the lower the number, the better. So in the center, we've got a thermally broken storefront system. Put that same piece of glass in it, same insulated glass unit, and now the system performance drops down to 0.39. So you can see how we've really improved the thermal efficiency of the frame going from a non-thermal to a thermally broken system. Then on the right is a storefront system, high-performance storefront with a dual thermal break. And the same line of glass in that drops the system performance to 0.36. So you can incrementally improve the performance of your frames by changing the framing type and change the glass type and improve the overall performance of the system. Here's some curtain wall examples, and you can see moving from the left to the right, different curtain wall options going from a curtain wall with a polyamide thermal break in it, which we consider the isolator caps here, which we consider thermally improved. It's not thermally broken. And with the same line of glass in it, that has a system U factor of 0.49. Now going to a thermally broken curtain wall with an EPDM gasket here, and that has system U factor of 0.45. A lot of people don't consider an SSG curtain wall as a thermal break, but it really is because there's no metal projecting between the two insulated glass units. And so an SSG curtain wall will give you a system U factor of 0.39. Then going to a high-performance triple glaze curtain wall is going to drop that down to 0.28. And that's using glass that has much higher thermal performance than what we've been looking at over here. We're looking at center glass U factor of 0.16. Something else to consider is condensation. Many patient rooms have higher humidity by design to help with the healing and reduce incidence of static electric shocks. The problem is that condensation can accumulate if not accounted for. interior window frames or glass surface temperature is lower than the dew point, condensation will occur. Note in the chart here that as relative humidity increases in the room, the dew point or temperature at which condensation will form in the interior frames of the glass goes up. So as the amount of humidity on the interior increases, it takes less cold to cause condensation to form on the glass because there's more moisture in the air. So CRF is condensation resistance factor. Where U factors, you want the lower the number, the better. With CRF, the higher the number, the better. So you can see we have recommendations for CRF levels here across the bottom based on relative humidity and the corresponding dew point. So always check ahead of time and make sure that you're getting frames that are going to meet your condition. And here's how you determine that. If you look at this chart, across the top, we have inside relative humidity going across here, going from 15% to 50%. This is outside air temperature going from -20 to 20. Let's say we were in an area where outside air temperature was 0 and we had 35% relative humidity on the inside, then we should have a CRF of no less than 5.9. So that's how you use this chart. It's going to show a correlation between outside temperature that's going to chill the frames a little bit and relative humidity on the inside and give you the corresponding suggested minimum CRF for your frames. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.